All right, so today we're going to be going into parallel and perpendicular slope. We're going to specifically be talking about the slopes that happen when a line is parallel versus when a line is perpendicular. As we know, when a line is parallel, they never intersect. And that's quite beautiful. They are always the same distance apart. They never intersect. Think railroad tracks, okay? So like this line right here would be parallel to any line that just stayed the same distance apart from that line the whole time. All right, so we're going to be deciding if they're parallel, and we're going to check out the slopes on each of these. So first things first, solve them both so they say y equals. So on this one, notice that we have to distribute the 2 on the left one, and then we're going to end up adding the 3. So we have y minus 3 equals 2x plus 8. So here we're going to add 3 to both sides, and I get y equals 2x plus 11. Now you'll notice the slope here is 2, and the slope here is 2. Because the slopes are the same, they change at the same rate. So because they don't start at the same location, these are parallel. All right, on this next one, neither one of our equations are solved for y, so we have to solve them for y. So we're going to subtract 2x from both sides for this first one, and we get y equals negative 2x plus 7. Then over here, we have to subtract 4x from both sides, and I get 2y equals negative 4x plus 14. Then we'll divide every single piece by the number 2. And I get y equals negative 7x, negative 2x, struggle is real, plus 7. Now, even though our slopes match, we have this other problem going on. If they start at the same place, that means that they're going to intersect at every single point. These are the same line. So these are not parallel. This is the place where you have to be most cautious when you just check slope. You also have to check that intercept. Are they the same point? All right, so here we're just deciding which of these are parallel. So taking a look at these, they're not all y equals yet, so we're going to have to do that part first. So I'm going to distribute my 3 on this one, and I get y minus 5 equals 3x minus 3. And then I'm going to add 5 to both sides. And I end up with y equals 3x plus 2. It's looking pretty good so far. All right, and on this one over here, I'm going to have to subtract x from both sides. And I get 2y equals negative x minus 4. And then I'm going to have to divide everything by 2. And one thing to remember right here is this negative 1 in front of the x is going to be important here because it's going to become a negative 1/2 x. And then negative 4 divided by 2 is just a negative 2. All right, so now we're checking slopes. You'll notice that there are 2 slopes with a slope of 3. But that means that we just need to check this intercept. So we've got a 2 and a 2. These are the same lines. So A and C are the same lines. They're not parallel. So let's go ahead and check the other one. So we've got negative 1/2. Is there any other line with a slope of negative 1/2? It's right here. It's D. Now that we've checked that, we now need to check the y-intercept. So we've got 4 and negative 2. Because these y-intercepts are not the same, we can say that B is parallel to, that's a symbol for parallel, D. All right. Okay, let's go on to perpendicular lines. So 2 lines that intersect at 90-degree angle are called a right angle. They're called perpendicular. The symbol for perpendicular is this symbol right here, and we tend to mark angles with this little box thing in the corner when it's a right angle. Okay? So, what's interesting about perpendicular lines is their slopes multiply to negative 1. In other words, they're opposite reciprocals of each other. So let me show you what I mean by that. So right here, we've got the number 2. If I want to give the opposite reciprocal of the number 2, this is actually 2 over 1. So I want to flip it over, and I want to change the sign. So it'd be negative 1 over 2. On this next fraction, I want to flip it over, so it'd be 3 over 2. And I want to change its sign, so it's negative 3 over 2. And this next one, again, I flip it over so it becomes 5 over 1. And I change the sign, it becomes negative 5 over 1, which we all know is negative 5 when we reduce. Yes. Okay, on the second line, we've got negative 3 over 1. If we flip it over, we end up with negative 1 over 3. On this next one, we've got negative 1/4. Oh, I forgot to do something. What did I forget to do? I forgot to change the sign. So it should be positive 1 over 3, because we changed the sign. Okay, and this next one, when we flip it over, it becomes 4 over 1. And if I change the sign from negative, it becomes positive. So the answer here should just be positive 4. Now, what's interesting about the reciprocal of 0 is you can think of this as 1 over 0. This is undefined. So this is why the slope here, this flat horizontal slope, is perpendicular to this undefined slope. This is mathematically y. Visually, we can see it. It's fairly easy to see. But mathematically, it's because when you take the opposite reciprocal of 0, technically this should be negative 1 over 0, you get an undefined thing. It's a number that doesn't necessarily exist. Because this is asking what times 0 equals negative 1. Well, there is no number times 0 that equals negative 1. Alright, so we're deciding, are these perpendicular? And we're going to check the slopes here. So first things first, solve it for y. So we're going to subtract 3x from both sides. And we get y equals negative 3x plus 5. Okay, that looks great. Alright, on this next one, we're going to add x to both sides. And I get 3y equals x plus 4. And then I'm going to divide everything by 3. So then I'm left with y equals, now remember there's an invisible 1 right there. So it becomes a positive 1/3 x plus 4/3. Now, this is what we have to check. Is negative 3 an opposite reciprocal to positive 1/3? Yes. So these are perpendicular. All right. I want you guys to now look at these and see if you can figure out which two lines are perpendicular. So solve each for y, then compare the slopes. Remember, it's opposite reciprocals. Then I want you guys to try these out. So it gives you the equation to a line, or 2 points, and it wants you to identify what slope is parallel and what slope is perpendicular to that same line. All right, and once you do that, go ahead and write your recap, and you are done for today.